Hey everybody, welcome back to Neuroscience. Today we're going to go through the motor system components. So the alpha motor neuron is going to innervate the extrafusal muscle. So the extrafusal muscle is going to wrap around the intrafusal muscle. That is the name. It's responsible for contraction. The gamma motor neuron is going to innervate the intrafusal muscle, and those are going to surround. That's going to be surrounded by a capsule, and then that's surrounded by the extrafusal muscle. And the extrafusal muscle is going to be longitudinal in their orientation, while the intrafusal muscle are more like fusiform shaped, right? So they're going to be innervated by both sensory and motor nerves, and they lie parallel to the extrafusal muscle. So they will contract in changes to the muscle velocity. So they will be innervated, or they're going to receive the action potential whenever the muscle length changes, I should say. So in terms of like active contraction. So as you can see here, the dorsal root ganglion is going to be kind of like the stop point for everything as it goes through the dorsal horn. Then there's going to be the fibers that's going to innervate both the motor end plate and then the actual fiber itself, and then the Golgi tendon organ. We're going to go through that in a little bit. So the gamma motor neurons are going to innervate the intrafusal, as you can see there. The sensory neurons are going to come from the CNS, and all of that's going to be innervating the motor unit. So the intrafusal muscle spindles, there's going to be two types, the nuclear bag and the nuclear chain. There's much more there's much more chain fibers than bag fibers. And the group 1A afferent nerves are going to be the sensory nerves, and they are in an annular spiral fashion. So they're going to wrap around the intrafusal muscle. And they will innervate both the nuclear bag and the chain fibers. The group 2 afferent are going to innervate only the terminal ends of the nuclear chain, and those are in a flower spray arrangement. This picture's not too good about it, but the next picture in the next slide is pretty good at describing it. The dynamic gamma motor neuron will innervate the end plates, and the static gamma neuron is going to spread over longer distance, and those will end in the trail endings. Those are more responsible for proprioception. Okay, so the afferent neurons are going to send the information to the spinal cord. The spinal cord is going to send the information through the anterior horn cells to the alpha motor neurons to allow the contraction to occur. The contraction is continuous because both the extra and the intrafusal muscles are going to be contracting. Okay, so they contract together due to the stretch reflex. So a stretch, so if you pick up a heavier object, as long as it's not air, right, there is going to be a bit of a stretch in the sensory sensory part of the intrafusal muscle. So it's going to activate the 1A afferent neurons and activate the alpha motor neuron, and then the extrafusal muscle will contract. Okay, let's go through it. Stimulation of the muscle spindles, that's going to activate the alpha afferent neurons. It's going to send the information to the spinal cord. Spinal cord is going to process it, and then the information is going to come out once processed through the anterior horn cells back over to the alpha motor neuron, and then that goes to the extrafusal muscle. So when the alpha motor neuron is stimulated, then the gamma motor neuron is activated. Gamma motor neurons can't be activated all by themselves because there's no direct connection to the 1A fibers. So co-activation is when the descending path, so it's already been integrated, it's sending the information, is going to activate both the alpha and gamma motor neurons simultaneously. So if only the alpha motor neuron are activated, the extrafusal muscle cells will contract, and the muscle spindles are going to be the tension is going to release, and no action potentials are fired. So it's not going to be able to signal any further length changes. Normally, both are contracted. So what happens in alpha motor neuron activation, but no action potentials are fired? So any kind of toxin, paralysis, lesions, that's going to occur because both have to occur, right? Okay, so in an unstretched motor muscle, the action potentials are going to be firing at a constant rate to maintain the tone of the muscle, right? Stretched muscle, that's when you pick something up or move something with your foot. That's going to increase the rate of action potentials. So that is pretty important to have the action potentials firing constantly. The Golgi tendon organs are going to lie in the thick portions of the tendons. They are going to be made out of 1B fibers. They sense tension and proprioception. The Golgi tendon organ reflex is basically a protection reflex. If you pick up something that is just too heavy for your muscles to handle, you will drop it. Even if technically you can pick up more than, or you can hold more than that weight, but it's going to damage a lot of fibers. So for example, technically I'm pretty sure I can lift 100 pounds with just my arms, but the cost is really high. I can fracture the bones in my hands trying to lift it up. I can tear a lot of very delicate tendons in my hands and in my wrists holding whatever object that's 100 pounds up. So it's a protection reflex. And opposite of that is the motor spindle reflex, where the alpha 1 motor and the gamma motor neurons are co-stimulated. We kind of went over that in the previous slide. Okay, so what is a reflex? A reflex is an involuntary action that skips the brain or conscious control. There are a couple types. The autonomic reflex. So this is hypotension, hypertension. The obvious example is when you start waking up and you sit up. You can immediately feel the blood rush to your head, especially when you've been sleeping for a while. And then your heart rate picks up. That's to maintain homeostasis. That's to maintain the new change in orientation, and now the heart has to work against gravity. So the reflex is to increase blood pressure to perfuse the brain. The cranial reflex are the reflexes that your cranial nerves control. An example is the eyes and head reflex. So when your eyes track something, automatically your head turns. But once your head turns, your eyes also have to compensate for the it has to also compensate for the movement of the head, right? So in order to the vision to remain upright and linear. Spinal reflexes are going to be when you tap on the tendons, and there is a reflex in the limbs. That's also the somatic reflex. So the withdrawal reflex is specifically a reflex, a flexor reflex. When you step on something sharp or something hot, burns you, you withdraw. So you flex the foot or the arm to get away from the adverse stimuli. The cross-extensor reflex, it helps you maintain balance when you take your foot away from something. One leg is kept extended and one leg is flexed for withdrawal. The monosynaptic reflex is a direct communication between the sensory and motor neuron. So this is going to be your tendon reflex, direct communication. So you tap on the tendon, it's going to like jerk. The stretch reflex is going to be contraction of all the synergistic muscles. So the stretch reflex is basically like you're already holding things. Things are contracted. Like I'm holding all my textbooks. And then all of a sudden, some asshole friend decides to put in another textbook like on top of the pile of books that I'm holding. There's no relaxation. There's going to be more contraction of all the synergistic muscles. So maybe there's like an extra load. I'm already contracting my like biceps brachii in order to keep all my books up. But so like maybe I have to actually start using more of like my pectoral muscles or my like shoulders because of the added load. The polysynaptic reflex is going to be an inner neuron that allows the sensory motor communication. So this is going to be your pain reflex. So you feel the pain, you withdraw your hand. Contraction agonist and relaxation of antagonist. More like when you're jumping away from things because you have to, it's a little bit more complex than monosynaptic reflex. But even then, if you're like kicking out, you have to contract your agonist and like contract your hamstring. No, cannot hamstrings, I'm sorry. Contract your quadriceps and relax your hamstring muscles. The tonic stretch muscles or reflex is going to just help you maintain posture and continue to stand even when you're tired. Like, just because your feet hurt a little bit doesn't mean you crumple to the ground. That's it for now. Thank you for your attention. And this is a pretty good mnemonic. That's not right. Rhyme. Memory technique, to remember things. So 1, 2, buckle my shoe. This is your ankle, so S1, S2. 3, 4, clean up the floor. So you're on your knees. This is going to be L3, L4. 5, 6, pick up sticks. You're gonna be using your supinator and your biceps, so that's C5, C6. 7, 8, open the gate, so triceps. You're gonna be pushing, so that's going to be C7 and C8. This is this is pretty obvious, right? Your trunk and upper extremities, C, lower extremity, L, and S.